Give it up for Eric.
Thank you. Thank you for the intro, and thank you for Gnosis for hosting this. This is a really awesome event. I am one of the core devs at Livepeer, and Livepeer is a decentralized video streaming network. Before I get into it, I want to see a show of hands of how many people have heard of Livepeer or know what it is. All right, about half. OK, so I have 20 minutes, so I'll go through this fairly quickly, so we have some time at the end to ask questions. So the thing about Livepeer is that Livepeer is open source, and it's open access video infrastructure. This is, in fact, something that's rare in the video world, because unlike the blockchain world, most of the video software that we use today on the infrastructure level is all proprietary and run by software licenses and platforms that are owned by centralized companies. So before we get into how Livepeer works, we have to kind of take a look at how video streaming works on the internet today in the non-decentralized world. So usually we have a broadcaster. It could be a phone. It could be these guys with cameras sending a video stream in RTMP format into a cloud-hosted media server. Now this media server takes the video stream in, and it does this thing called transcoding, which is really crucial for the video to be able to be dispersed around the world to all the devices that people are watching them on, to all kinds of video networking conditions. Imagine someone sitting at home with a high-speed internet versus someone walking around outside with a smartphone connection. And what the transcoding is doing is it's turning that one video stream into many, many different video streams that all look like the same video stream, but with different bit rates, so that different types of connections can read them, and also different video codecs for different video players that speak those codecs. And the media server also can add DRM, which is to preserve the privacy of the video. It could also store it for later playback, and then it outputs this video into a CDN using an HLS or Dash format. So the CDNs are the infrastructure that kind of runs the internet, right? They deliver a content from one location to all the users in the world. So you hear companies like Akamai or Fastly or things like that. They are basically in charge of taking one file, replicating them around the world into millions of the same files, and delivering them to the people. The people is on the right, on the other side of the screen, which are all the devices. So that's kind of how video streaming works today. And what you notice is all of these cloud-hosted services that are doing the work. And effectively, because there's not many of them, effectively they create some sort of a cartel that artificially keeps the price really high. So for example, it costs $3 per stream per hour just to process the video. If you have thousands of video at the same time, it's $3,000 per hour per hour, right? So that adds up really high, really quickly. So what Livepeer is trying to do is really turning all of those cloud-hosted services into this open video network that's incentivized with crypto economics. And using the tools like Ethereum, like Swarm, and some of these decentralized projects in order to do that. And Livepeer itself is a protocol that creates the incentives and the validations so that we can take the trust out of this whole equation and have a broadcaster just be able to trust a decentralized network to do the exact same work that it was doing today. And there's a really important thing here is Livepeer is not only just trying to make things decentralized. It's also trying to make things 10 times cheaper than the current solution. And I'm going to get into how that happens. So we already talked a little bit about why decentralization is important. Here we're going to talk about only the transcoding piece, which is a really crucial piece in this whole workflow. So let's go into how the protocol works there. What we do at the beginning is we have a transcoder. A transcoder will advertise its capability and price with the Livepeer smart contract that's running on the Ethereum network. Now, a lot of these transcoders can do it at the same time, and they can be any computer running in your garage to a big cloud-hosted instance. Now, when a broadcaster comes along, it will ask the smart contract for a transcoder within its price range. And the smart contract will then assign this job to a specific transcoder. And at this time, because the broadcaster is looking at the blockchain, it knows who the job is given to. And the broadcaster will start pushing video into the video storage. Now, when the broadcaster is pushing the video out, it's signing every segment with its private key. And what it's saying to the world is, I am the broadcaster, and I prove that this is the video that I have published, and not anybody else. So now the broadcaster, when they see the video and when they see the signature, they can start doing the work. And as they're doing the work, they also create another signature and writes it onto the blockchain. And what this is saying is, I have taken this specific input to create this specific output, and I'm creating a hash and writing that hash on chain so that it's tamper-proof. Now, we don't have to do this for every single segment because we can just create a Merkle root of thousands of segments at the end and writing it once onto the blockchain. Now, when the transcoder writes the proof onto the blockchain is also when they get paid. So for every single segment that it writes, it has a price, and the broadcaster will pay the transcoder according to the amount of segments that it writes onto the blockchain. And at the same time, the transcoder will write the result back into the video storage, and the broadcaster can use the result to broadcast the transcoded video to their viewers. Now this is all good, but how can the broadcaster trust the transcoder is doing the right work, right? Because it can just be it's just a hash. So now when the transcoder writes the proofs on chain, the smart contract will pseudo-randomly send challenges to the transcoder, and the transcoder will have to provide the proof that it has done the right work. Otherwise, it will get slashed. So this gets into computation verification, right? Which we all know is very expensive on chain. So we have all these different off-chain solutions to solve this problem. Livepeer has been working with a team called TrueBit for a while now. In fact, we have already built a prototype that does TrueBit using the Livepeer protocol. And what that does is it completely decentralizes the verification process so that we don't have to trust a single party to do the verification, which means we can execute all of this transcoding heavy computation off-chain and still trust that the computation is done correctly. So not only do we have to decentralize the verification, we also have to figure out how to do non-deterministic verification. Now, this is something that TrueBit does not do, right? But which is required for video transcoding, because a lot of video transcoding is done, for example, on a GPU, which has floating point calculations. And what that means is, for every video segment, for the same video segment that you transcode, you could get different results on the bit level, even though the picture looks the same to the human eye. And here, to get around this problem, we use video fingerprinting technology, which is something, for example, YouTube uses for content right takedowns. So whenever you upload a video onto YouTube, they're able to tell that even if you slow the frame rate or slightly change the picture a little bit, they can still tell it's from the same picture. So we use the fingerprinting technology, and we also use video quality score, so we can tell whether the work has been done, the transcoding has been done, and to what quality has the transcoding been done. And all of this, because the verification technique is done in a deterministic way, that means even though the transcoding is done in an undeterministic way, we can still verify that on chain deterministically. So now that's all good. So we can trust this network to do our computation, and it can be trustless. It can be done in a decentralized way. But still, we need to make sure it's cheap, right? And the way to do this is we do something called a video mining. So we recently published a blog post and done some benchmarking. And what we found is that we're able to cut down the price by 10x from something like a traditional cloud-hosted transcoding service like Amazon or Google. And the way we do this is we plug in to the existing cryptocurrency mining infrastructure. Because all the GPUs that are out there that are mining cryptocurrency all have a video transcoding ASIC sitting on those GPUs. And because they're not utilizing those GPUs right now, we can plug into a huge pool of unutilized resources. And because the cost of doing transcoding is so much higher than doing cryptocurrency mining, we have about 1,000x margin to play with here. And that's how we're able to cut down the cost so much. And to do that, we create competition between the transcoders. So we do this thing called a transcoding race, which is not dissimilar to how like Bitcoin mining works. So the transcoders are all racing to do the same video transcoding for a specific stream, and the first person who gets the results back wins that small reward. And this is how we're able to get high redundancy on a video stream and increase competition to push down the price. And this provides a scaling factor in the whole network. And it provides incentive for computation efficiency, it lowers the latency, and it creates a massively parallelizable video transcoding network. And we're also planning to add geolocation here so that when the broadcasters are broadcasting a video, they're able to find the closest ingest source to push the video in. So, of course, when we have this open, decentralized, open access network, some of the hard problems start to come in, right? What about codec licenses? And what we offer people is that as open source developers, we encourage people to use open source video codecs. So the traditional codecs that people use is X264 today, which is actually closed source. But there are open source alternatives to that. For example, VP8 and VP9, and there's a new source coming out called AV1 that will solve a lot of these problems. Another thing is content blocking, right? So as video is like a very powerful medium for storytelling, and there's all kinds of video content out there, from good to bad to outright illegal. How can we stop illegal content from getting onto the network? And here, similarly, we give the choice to the node operators. So the node operators can decide what kind of content, what kind of sources they want to be processed through their node. And as a network, the network will provide choices to people who want to process different types of content. So for the last bit, I want to talk about why we're using the blockchain in the first place, right? Of course, we can build video processing. There's already a bunch of technologies that exist. We can plug into the crypto mining world in a centralized way as well. But what we're trying to do here is to think about creating a long-term project that has sustainability. And what does that mean? Today, when we're looking at creating software, right, we have to make a choice. Do we want to create a for-profit company so that we can use the profit from the company to continue to fund the project, or we can create an open source software so that people can use it for free and it's always out there, and as long as the software is good, it can be sustainable in the long term. And what I think is that blockchain creates a new type of sustainability in software development by creating a token economy. Right? So in a token economy, there are different types of contributors who are providing different values into a network. And if you create a token economy correctly and have the right design, these actors can all work together to create a good market so that people's incentives are aligned and people are working together to grow the network. So let me use Livepeer as an example. Right? Livepeer is a delegation. It's a delegation network. And what that means is token holders will delegate, which just means voting, for the people who are doing the work. Right? We talked about orchestrators. So the orchestrators are the ones that are getting the inflationary rewards from the protocol. Now the broadcasters are paying the fees in order to use the orchestrators, and the orchestrators are getting the transcoders to do the work for them, and in exchange paying them fees. Right? And the token holders here get some kind of payout based on which orchestrator they voted for, because one of the things that the orchestrator campaign with is a reward cut that they pay back to the people who delegate toward them. So this is all nice, right? We have the token holders, the orchestrators, the transcoders, and the broadcaster all kind of helping each other to grow the network. But what about if you are an application developer? How can you participate in this ecosystem, in this economy? So one thing you can do is you can create an app, right? These token holders need an application interface in order to do the voting. For example, imagine when you have Casper already, you need to see a list of Casper nodes, validation nodes, in order to stake your Ether toward one of those Casper nodes, or something like that. And if you're a really good app developer, you can get people to pay you to use your app, right? But in fact, there's another way for an app developer to get paid, and that is in this inflationary token model, right? Because all the inflation is going through the pool orchestrators first. And the pool orchestrator is taking a percentage of the cut in the reward before it's paying the rewards back to their voters. So if you're creating a really popular app, you can campaign in your app to say, hey, I'm also running an orchestrator. Why don't you vote for me? And because a lot of people in the ecosystem are using your app, an app developer has an unfair advantage in this sort of delegation scheme, and they can use that advantage to get long-term payouts every single day from participating in this economy. And that's how an app developer can build a sustainable project and even a sustainable business in an economy like this. And another way to do that is to create an actual business on top of the protocol that interfaces with the outside, right? So imagine when we talked about cutting the price down by 10x. When that's the case, there's already a lot of video out there being transcoded today. They're all looking for cheaper prices, but maybe not all of them are looking to pay with crypto. So a business can easily be created to abstract the crypto layer out and still charge people in fiat, but capturing a margin and using the Livepeer network to do a much cheaper transcoding service for other people. In fact, today, everybody can participate in Livepeer. So we launched on the Ethereum mainnet about 2 months ago, and since we have seen a lot of interesting activities on this delegation mechanism. What we've done is, during the Genesis block for Livepeer, we have put about 65% out of the 10 million Livepeer tokens into a smart contract. And anyone at that time with over 0.1 ETH in their address is able to claim a portion of that 6.5 million tokens. So all you have to do is to go to this website, and if you hold the key, you can generate the Merkle proof automatically in order to claim that about 2.5 tokens. But what's more interesting is there was a slow start period, but after this, you can start claiming for other people, for your reward, you're able to get a small percentage of their token to yourself. And this percentage increases over time, so that tomorrow, if you call it, they will get all the tokens, you get nothing. But in 18 months, if you call it, they'll get nothing, and you'll get all the tokens. So there's an interesting game that's about to start. So that's all the time that I have. Thank you for being here.